Hello, everyone, and welcome to another edition of Code Remix Weekly. We're your regular hosts, Sam and Tim. How you doing, Tim? It's been a little while. Where were you last week? I assumed it was a conference. Was I right?
Yes, it was a conference. It was JFall, the biggest Java conference in the Netherlands. So
Nice. How was that?
yeah, pretty good. Yeah, we did a workshop together with a friend of mine, and then on automating your towards better testing practices, and of course,
Nice.
OpenRewrite made a feature there. So
Of
it was
course.
a lot of fun. Yeah.
Nice. Did it was like how big of a conference? Oops, hit my microphone. How big of a conference are we talking here? Like 100 people, 200 people? 500
There
people?
is 1,800 people in one room in Ede, which is about an hour's drive from my home.
That's
And,
pretty good. That's pretty
yeah.
good.
And it sold out in, I think, 3 minutes for the first block of tickets, and then another hour or so for the remaining block. So quite a
Nice.
lot of interest.
Nice. But hold on, you say an hour's drive from your home, but the trains and bike paths in the Netherlands are excellent. Did you drive there?
I did drive, but only because I had to be in like 3 locations in one evening. So I figured I'd take the car. Yeah.
A man in demand. Well, glad to have you back. Did you see any sessions at the conference that were really cool that you're like, oh man, everyone needs to know about this?
I only saw like 1 or 2 where you go support your friends, and then apart from that, I
course.
was mostly busy catching up in the hallways and things like that. So
That's always one of the fun things about going to a conference, and especially a conference like Code Remix Summit, where we'll have the hack track, which will be dedicated to such encounters. It was fun last year. It'll be fun this upcoming year. So yeah, look forward to that, everyone, and obviously register for it.
Oh, we lost your audio there. Did you mute yourself?
No, not muted. Can you hear me now?
No, not back yet. Unless I messed something up. Kevin can hear you, so this is going to be interesting. Let's check.
Okay. We're getting reports that everyone is audible except to Tim. Thanks, guys.
I'm gonna switch my headphones. Can you say anything?
Yeah, anything.
No.
Nothing.
I'm gonna refresh.
Maybe Tim has been stricken deaf in real life. Let's hope that's not the case. That would be tragic. Oh, thank you, Kevin, for translating. That's always beneficial. I've always wanted an English to English translator so that people get what I'm saying. How's it working? How's it working now, Tim? Anything?
I can hear you now, but it doesn't work on my headphones. So I'm hoping that the
Did the speaker doesn't pick up?
Work.
All right. Yeah. Well, so far so good.
All right, let's go.
Kevin doing his job admirably. So, what announcements do we have for the week, Tim?
Yeah, sure. Let me share screen. This one. So, of course, we did a release last week, and while we were a little slow getting the docs updated, just because of technicalities, we now finally do have a release that you can all refer to. So if you go to this page, you can see some of the highlights and link into the docs of everything that's new. And just call out a couple of things. There's some preliminary recipes in there for Spring Boot 4. Of course, we're expanding those still leading up to next week's release. But then also there's been some high visibility bug fixes for folks using Maven and expecting their resource files to be updated as well. So that's in there as well. So pretty pleased with the result. And if you want to see the full details, just go to our OpenRewrite docs, and you'll see that we have tons of new recipes, very closely inching towards the 5,000 open source available recipes here as well. And then just continuing to expand that catalog ever more. So then beyond that, we have a new blog. So if you go to the Moderne blog, there's a link right now that you can see with a new blog by Brian and Patricia on bridging the context gap, how Modi unlocks AI for real-world code bases. So I can recommend this one. Just it goes into Modi and how we use that and how that surpasses what is currently available. So recommend to go check it out as well. Then Beyond that, we also have the Moderne newsletter, which went out yesterday. So if you're not already subscribed on LinkedIn, then I recommend you do so. And then you can get some highlights that are new in the past month and just see that forever updated as well. Now, looking ahead, we have a couple of things. So there's a webinar next week, next Wednesday, I believe, where we're going to talk to the folks at Uber who have been using our open rewrite recipes to migrate off of JUnit 4, I believe, onto JUnit 5 and 6. And they're going to show how they did that on 1 million lines of code in just a couple hours, I believe, for a couple of weeks. So be sure to check in, and we'll hear all the details then. Also, next week is that Mark is going to be at a QCon event in San Francisco. So if you want to check out more about using OpenRewrite and Moderne to your advantage, and definitely check that out as well. And then finally, just today we finished the intro course for November for folks looking to learn more about writing open rewrite recipes. And then next week, we're going to have the advanced open rewrite training, which is in the European friendly time zone. So I can get to do this in my afternoon rather than my late evenings. So look forward to seeing any of you there. And then, of course, today was a lot of fun. We had, I think, 20 to 30 folks stay till the end, and just a lot of questions on how to get started. And hope to see you all there. And then also next week, but thankfully on a different day, I have another workshop to give on migration engineering with Open Rewrite. So if you are in the Utrecht area, you can go to the Rabobank, where I'll be giving a workshop on using Open Rewrite and Moderne to upgrade your services and maybe tie in a bit of that Spring Boot 4 migration to get you all going with the next release next week. And then finally, as a fun bit, a good friend of ours sent us a photo of a T-shirt that we shared with him, I think, a couple of years ago. I know I have one of these, but not a lot of folks at Moderne have this particular T-shirt still. And he shared it from Jakarta. So on Java, there's now a T-shirt for Open Rewrite being put to well used there. So really fun to see.
But did he use a recipe to rename it that from Java X is the question.
Don't think so. So I think Jakarta is, that's the city, I think, on the island of Java. And you have Kotlin, which is a small island. You have Lombok around the corner as well.
Wait, Lombok is an island?
Yeah, that's another island.
And Kotlin's an island? My mind is being blown right now. I heard of Java, the island, but these ones are news to me. This is great.
Kotlin is an island, but it's in the Baltic Sea, I believe, like just off of St. Petersburg, if I'm not mistaken.
Well, obviously, all the programming islands float in the sea.
But this I don't know. It makes you want to develop new languages and features with that whole naming scheme going.
Yeah, Kevin. Apparently, it is. My mind is blown too. This is crazy. Do we have enough Polynesian islands for all the new programming languages that are coming out? I mean, college students are Indonesian islands. College students are creating a new programming language all the time. Do we have enough cool island names for all of them? Let's cancel our regularly scheduled topic. I think this is the most important thing. We got to look at the map and find all the islands with good programming language names.
I think they have a couple thousand islands in Indonesia, so we should be fine while still. So, the only thing we might want to look at is how many of those are well above sea level, because that's the one worry we might have.
Yeah, you'd want them to last for sure.
Yeah. Oh well. So Kevin shared that a couple of thousand is an underestimation, so 17,000 plus is more like it. I think we should be good. Still. It's better get started on those parsers than I imagine.
Yeah, absolutely. Well, in just a moment, we'll be talking with Mark Heckler about post-quantum cryptography. But as a internet-addled millennial, I have always been a big fan of internet memes, and as a programmer, always a fan of programmer memes. So I have collected my top 5 programming memes of the week, and just thought I'd take just a minute to share those with all of you. Feel free to hit me back with your favorite programming memes in comments or tweets or what have you. But the first one I have here is the simple how I feel after successfully making a button blue. And this really resonates with me as, my first foray into programming. was making websites, and just like the idea of like, even before you get to programming, before you get to JavaScript, just like laying code out in an HTML document felt magical. And then later on, you get a little bit of code in JavaScript, and you can make something turn blue when you click on it or hover over it. That feeling of discovery, of creation. It provided a lot of impetus to go on and learn more of more topics, and that same like bit of joy, I think, is still a great motivator for a lot of us. So I like this one. Number 2 for the week is Oppenheimer sort, which is a novel sorting algorithm that whatever collection you pass into it, it returns an empty collection, which is always sorted. So so this is pretty good. I'm also a fan of Stalin sort, where you go through the collection and eliminate every element that isn't already in sorted order.
Yeah.
I think these are maybe relatives of each other.
I knew that one. I was wondering what made this one special, but yeah, just clear out everything. That works. Yeah.
Uh-huh.
I imagine it's fast as well, right?
Yeah, surely very fast. I mean, this has got to be constant time, which, you got all those proofs about, sorting algorithms being like at best in login or whatever, but clearly they haven't heard of Oppenheimer sort. Someone's getting a PhD off this baby. To the Will Smith movie, an Asimov story, I, Robot, where an LLM and a human in an anthropomorphic casing challenges Will Smith about or counter challenges Will Smith, and I think with with all of us reviewing LLM generated changes and participating in creating them ourselves, there's a little bit of looking in the mirror that should happen with anyone's usage of of a tool. Remember that as you wield the tool also wields you, and I think that is never more relevant than with LLM based coding. And this one I just related to a lot, as I fix a lot of customer issues. And sometimes you put a fix out there, and there's more to it, and that it's probably going to come back to bite you at some point. But for now, you're getting the good feedback, and that's something. So maybe you could scramble behind the scenes to fix the rest of the issue before it blows up in your face, or just hope that someone else will triage that and not realize that it's because you didn't fix the whole thing the first time that they're now dealing with issue version 2 Electric Boogaloo. Yeah,
I may or may not have pushed 1 or 2 fixes today that had this exact caveat in the disclaimer. Like, we're making it better. I know there's still holes in here, but we're making it better.
So long as it's better than where it was, that's a nice thing. And then the final meme I have, not because I necessarily, this is the second to last meme. Classic, love a cat, love a semicolon. There's a lot of Python fans out there who are like curly braces and semicolons. I scoff at such things. All the relevant stuff is encoded in indentation. And the people who react that way have not spent a long time trying to debug why their code doesn't do the right thing because something wasn't indented exactly where they thought it was. In our own open rewrite ecosystem, the YAML files that define a declarative recipe, it's very easy to think you're configuring a recipe with a particular parameter and not actually be, because the indentation is slightly off, and we don't throw an error about that. Maybe we should, but anyway, it's always nice to appreciate the humble semicolon cat. And now for my final programming meme of the week, and this is the best, not because it immediately got, or I don't know if it's the best, but I spent the most time on this one because I didn't understand it, and it sent me down an hours-long Wikipedia rabbit hole trying to understand German philosopher Ludwig Wittgenstein and what he might have thought about all of your shell script commands. And so I'll just share you a little brief bit of my Wikipedia research on Wittgenstein. He was a philosopher of logic, math, cognition, language, who got started as doing like aerospace. It's right to call it aerospace. I say aeronautical engineering. They weren't going to space quite yet. And he had some like novel propeller designs that were very hard to manufacture. But he decided that engineering was too much trouble. Went into philosophy, and he had a lot of interesting sayings and thoughts about the nature of language, cognition, and language. It ain't what you say; it's the way you say it. It's the context in which you say it. Words are how you use them. We believed that that language shared the logical form of reality, but was not itself reality. That language was a tool, something that was derived from truth, but not in itself an expression of the truth, which is related to the idea of like the map is not the territory, but is useful because it corresponds to something real. That language is an abstraction with the relationship to truth, not the truth itself. And he had some fun quotes. Philosophy is a battle against the bewitchment of our intelligence by means of language, which it's very easy to fool yourself with words and and to circumscribe your own thinking with what you assume that you know. And if people never did anything stupid, nothing intelligent would ever get done. And so after going down the rabbit hole a little bit on this guy, I still honestly have no idea what he would think about your ZSHRC. Yeah, exactly, Kevin. It is. This is not a pipe. A similar idea from a famous piece of artwork that depicted a pipe and was captioned with "This is not a pipe." So I'm not sure what Wittgenstein would have thought about your shell script shortcuts, but interesting guy, worth reading about. A colleague and of Bertrand Russell, and someone whose work you definitely see influencing like Gödel and incompleteness theorem. And I think that he touched on some things that that you really see with like large language models today, where we've taken great deals of language and worked backwards from the text, just noticing the relationships of all the words to each other in order to statistically shake out some logic and knowledge. So yeah, I think I would love to know what Wittgenstein would have thought of a large language model. But anyway, our main topic for today is post-quantum cryptography with Mark Heckler. So welcome to the stage, Mark Heckler. How you doing, buddy?
Hey, thanks. How are you?
Doing pretty good.
I have to tell you, your pun game is really on point. I was loving that. I think you might have slipped one past Tim early on when you were talking about the Java X going to Jakarta. So Tim
I think Tim got it. He just didn't want to dignify it with the response. I saw you know I saw the sigh in his body language, which he as he just tried to kind of like that.
You don't want
to endure this remark.
No.
Yeah, I'm going to pretend I didn't catch that, and we're just going to step over here. We're just going to take this conversation over here. Oh my gosh. Yeah. I didn't say they were all good puns. I just said they were really, I mean, they were on point. They were awesome as far as
thanks.
Very well targeted. So
thanks.
Oh my gosh. Yeah. So, I mean, I guess we're going to talk about PQC, post-quantum cryptography, but I guess in general, you know, I'd kind of like, one, I'd like this to be more of a conversation where we kind of chat and bounce things back and forth.
Absolutely.
But two, I'd like to provide some context for anybody who might be tuning in, who's like, okay, what is PQC? Because, you know, I think often, I mean, in any domain, we typically assume everybody's at the same place we are. And that's never the case. There's people who are far further down the road, and there are people who are just starting on this conversation. And I think, you know, level setting is a helpful construct here. So, I mean, everybody has probably heard of cryptography, of encryption, of security, things like that. So I'm just going to kind of back up and start there a little bit, and then we can kind of launch in from that point. Hey, Georgie. Hey, nice to see you. I finally did remember to get my my chat, you know, comments up there until, you know, before afterward. That's always awkward when you're trying to respond and it closes out. So anyway, thanks for joining. So cryptography, I posted something about this not that long ago because I think it's helpful to level set what we kind of are talking about when we launch into the whole post-quantum cryptography problem and why it is a problem and why it's a particular problem. So, let's see.
When you're talking about level setting and getting everyone to the same baseline in order to have a productive discussion, I, of course, thought of this classic XKCD comic where two chemists opine about how much the average person knows about silicate chemistry and the tendency of all people to overestimate how much other people share of their specialized knowledge. I think this can contribute to imposter syndrome for a lot of people, particularly if you're surrounded by other experts on a topic all the time. You could be like, man, what do I know? What can I do that's really that useful or impressive? Anything I can do, Tim could do. So like, is it even a big deal? But you have a sampling bias in these things. So please continue. Tell us about the nature of cryptography and why post-quantum cryptography is a subject of conversation.
Yeah, so I think I like metaphors, so I'll probably be sprinkling the conversation with those liberally.
Oh, please do.
But for those who haven't given it a lot of thought, really, encryption is deemed strong or weak based on the economics of decryption, of decryption, right? Of teasing out what's really there. And whether that's a matter of determining someone is who they say they are, or the security and integrity of the message, whatever the case may be, encryption is deemed unbreakable for some period of time, long or short period of time, based on how hard it is as far as time and economics to crack it, right? So if something is deemed unbreakable, it's not because it's really unbreakable. It's just that within the realities that we all live in, it's not practical to break that. So the average person, the average company, the average nation state, it might take X number of days or months or years to break that algorithm. And Sam looks like he's locked. Oh, there we go. I was gonna say,
I couldn't tell if it was me or you guys lagging. I guess it was me. So that's
I kind of freaked out there for a second. I was looking over Sam, and Sam's like,
it always manages to catch you in the least flattering frame. It's right. Well, your face is normal 99% of the time, but it always stops when you're like,
where's Darth Jada to get a screen cap of that when you do it?
She'll be ready with the VOD.
Or Kevin, yeah. So anyway, so what that. Again, that's why we consider it to be unbreakable, even though really it isn't unbreakable. Conventional computing advances move that measure over some limit of time. Anybody who's dealt with encryption standards over the years knows that there are certain things that fall out the other end. So something that was the holy grail, that was the aspirational thing, that was what everybody was recommended to use, all of a sudden becomes, oh no. All of a sudden becomes, do not use this, or not recommended to use this because we have a better algorithm. And that's good, right? Constantly improving. But what happens is with conventional computing advances, that there's some period of time that algorithm is determined to be unbreakable or considered to be unbreakable. But I always kind of liken it, metaphor alert, I always kind of liken it to if you go camping in the woods and you step out of your tent and you see that there are a few smoldering campfires someone left, going overnight, and you think, well, I need to go put those out. So you go and you like throw dirt on them or whatever, and you're being a responsible human being. And that's great because you have a certain number of small smoldering campfires you put out before serious damage can occur. Hopefully, hopefully it's before any damage occurs. But the difference between that conventional computing and quantum computing is that, well, I'm going to grossly oversimplify here, but the real difference we're talking about today is the time frame, because instead of having these small smoldering campfires that may cause damage or that will cause a certain amount of damage over a certain amount of time, once quantum computing becomes economically viable in terms of sufficient power, sufficient economics, to where even a nation state actor or certainly any corporate or even a smaller actor can crack these algorithms, it becomes a matter of everyone expects those algorithms to drop like wet tissue. They will collapse quickly. So instead of walking out of your tent and seeing these, few smoldering campfires, you walk out of the tent and see the entire forest ablaze. All of a sudden your data's, compromised. Everybody has access to your PII, your personally identifiable information that you have on your customers, sensitive information that now you're liable for. And it happens like that. It's not a matter of, this menacing threat that's coming closer and closer. It happened. And now how are we going to deal with it? So the real problem with dealing with things from a post-quantum cryptography perspective, again, I'm grossly oversimplifying, but I want to take this kind of one piece at a time. But the big problem is the urgency, and as well as the lack of defined time. I was talking with somebody about this a little bit the other day, and they said, it kind of reminds me of the Y2K stuff. And I was like, Yeah, except
I
for
was
one
just about to
problem.
say that.
The big problem is the Y2K stuff. You knew when it was going to hit, right? So you knew as of like January 1st, midnight and 1 second of
Yeah.
2000, that there could be some
Mhm.
set of problems that could unfold. Now,
But it shares the property that you don't know going into it where all of the things you need to update to not be affected by the problem are.
yeah, now that's entirely consistent, but the difference is there was a hard and fast time limit, so everybody could kind of factor that into their planning. Whereas quantum computing, no one knows the exact moment that becomes economically viable. So it could be a minute from now, it could be a year from now, it could be 10 years from now. The only thing we know is that when it happens, everything changes, and we'd better be prepared, because there's not going to be a matter of, oh shoot, it happened, now we have to come up to speed, because by then it's too late. Literally, there's an old saying about closing the barn door after the horses escape, or whatever, something like
Right.
that. I love good colloquialisms. I just don't always remember them properly. But the idea is, once they're gone, right? So you can close the barn door all you want, but it's not going to save anything. So that's kind of in the similar situation. So that's why it's such a big deal. It's a hard reset, and it's an unknown time frame when that reset happens. So how do we prepare for that? And that's where you kind of get into there are certain things that change, obviously, and I've kind of covered those to some extent, but there are certain things that don't change, which is that good security hygiene. We typically call things like crypto agility. So are you doing things that make sense, that are how do I want to say it? Good code hygiene, good security hygiene, so that you can quickly swap out. For example, even now, you should be able to swap out your encryption provider without a lot of muss and fuss. And of course, things like Open Rewrite and Moderne Platform really facilitate that. Now, that's a general security precept, right? We should be aspiring to that every day, and have been aspiring to that for probably decades. But it's become more urgent with the idea that, maybe tomorrow somebody announces, hey, this is a big breakthrough, and now all of a sudden all of your encryption keys are void.
Right.
So a lot of it starts from a position of good security hygiene, and then good cryptographic hygiene, and then builds into, okay, now how do we determine that? How do we find the areas that aren't up to snuff? And again,
Right.
you mentioned, Sam, that every place in our code has things that aren't really ideal, right? So
Sure.
how do we manage to find those, address
Yeah.
those, and prepare for an immediate response when we need to be able to do it?
Absolutely. I mean, do you know what algorithms your communications are encrypted with throughout all of your applications, right? I mean, it's one of these things, like many things in programming, it could be defined anywhere. Maybe you're loading it from, some central service that that is configurable, and you could turn on a dime and adopt a new algorithm at any time you needed. That's probably like the end state of one of these migrations. The state that you're more likely to be at when you start is, well, AES is hard coded over here, and RSA is being loaded from this properties file. But on this other application, it's this YAML file that's saying, okay, we're using AES, or like we're using TLS 1.2, but like the key length is not big enough, and things have kind of organically been made to work together. But if you go and like change one of those, is it going to work with the other components in your system if they are not all upgraded in concert or changed in concert? And if you don't even know where all of the configuration that you're using actually is, then good luck changing anything in a deliberate way without inflicting outages on yourself, because it wouldn't do anyone any good to try to react to a hypothetical but plausible threat in the future and immediately cause yourself outages and other problems right now, because changing code is without operational impact is hard.
Yeah, exactly. And this is nothing that's specific to cryptography, but of course, every large enterprise, even smaller companies, really have a code estate of some size that has been created and evolved over time and across numerous different developers, development teams, and different security standards. Maybe certain things are known to be potentially vulnerable, but have been grandfathered just because we have to come back to that at some point, but it's not a burning issue, considered to be, at least initially, or at this point in time. So you have a lot of things that are wildly inconsistent. I mean, that's the world we live in, as well as how do I say this very tactfully? But sometimes we as developers do things because they're expedient. Yes, we want to approach that ideal. Obviously, we want to do things proper design, proper documentation. We want it to be robust and elegant and maintainable. But there are times that, and I've used this example before, when something goes down on a weekend and it's like Sunday evening, and somebody pings you and says this is a production system. It's as of Monday morning or maybe even Sunday evening, depending on time zones and when the actual bulk of the business occurs. But this has to be online by a certain time, or we lose $1 million a minute, or something like that. So you're the poor sucker who's on weekend call, and you're the one who actually gets to try to address this. And at that point, you have a couple of different options. You can pursue the elegant solution that might take you an hour to spin up, or you can do what you know will work or suspect will work and have it online within a couple of minutes and literally save your company millions and millions of dollars or euros or whatever the currency of your choice is. So you're going to have a pretty tough time.
This one almost made the cut on my meme list
Right?
earlier, but since it's so relevant to what you're talking about, I had to bring it back. Like,
Yeah.
oh no, production's affected, but I'm not on call, and it isn't my fault. Oh, that sucks for you so bad.
Meanwhile, the poor red shirt, they are
Exactly.
They got to get it back online. And
Yep.
all of us, even when we make those expedient trade-offs, we'll document something, we'll write it up, we'll do an after action, whatever the case may be, and we'll say this really needs to be addressed. But I mean, we, as much as we like to plan and follow processes properly, there are going to be times when it's going to be very difficult to come back and close that loop and to fix it. Maybe even take a production outage to fix it right, so it just doesn't happen. So again, I know we're kind of I guess deviating from the actual main path of the conversation, but it's all so relevant that you've got this vast code estate which follows to varying degrees various different security profiles and postures and capabilities. Poor Kevin. Okay, well, anyway, I didn't say your name, so maybe if we say a different name 3 times, I don't know, maybe that'll work. Anyway, so anyway, kind of follow down the rabbit hole, because I want to kind of go through this a little bit, and then maybe we can have a more general conversation. But we started working with this in terms of ways to determine patterns, right? So if you're looking for certain patterns that are, well, I should say anti-patterns, really, that are problematic, and you address those. Now, that can be done with a lot of different kinds of tooling, but it isn't always done well with a lot of different kinds of tooling, because you have to be able to do certain things and eliminate a lot of false positives, or not miss. I mean, we talk about false positives all the time. We also
False negatives, also a big problem.
Yeah, when you miss the actual vulnerability, that's an even bigger problem.
If you think you fixed it but you can't, that's then you're really screwed, because you're not even looking for the problem anymore, because you've convinced yourself it doesn't exist.
Yep, you're just happy as a clam waiting for doom to fall, right? But yeah, so I mean, we've talked to different organizations and different people and said, look, what are the patterns we should be looking for? I know this will come as a huge shock to anybody tuning in, but the Moderne platform is really good about full exploration and understanding of your code. We often refer to it as a data warehouse for your code, and that's not an overstatement. I know I don't have to tell you two this, but just for everybody else who may be joining in or viewing later. But the ability to fully explore, I guess for lack of a better word, the full type attribution and deep understanding of your code through multiple levels of dependencies in levels, as I like to say. So just however many, understand the context, have everything in place to where you have that full understanding of this thing that you're seeing in your top level code that is referenced and draws upon and instantiated from something. Yeah. Again, several levels deep. So that allows us to, with a high degree of fidelity, to determine if something is a problem or not. So patterns is one aspect of it, right? And Sam kind of alluded to this earlier. If you're hard coding an encryption algorithm, that's probably not a best practice. I always typically hide from the term best practice because what's today's best practice is tomorrow's anti-pattern or discouraged practice. So I usually lean into the like best practices of now or better practice or whatever the case may be. But the idea is that that you want to not have things that are hardwired in any circumstance, because then you can adapt that much more quickly with something like the Moderne platform. One, you can find it better, and two, you can address it faster. So when that the forest truly is on fire, you can quickly remediate and move on with much less damage than if you had to spend the next 6 months trying to go through all of your code scattered here, there, and yon. So pattern recognition is one thing, but pattern recognition, again, you can do with a lot of different tooling, not as well, but it can be done. So then you have to get into how do you determine when something actually does apply. And that's where we get into something called taint analysis. So the idea generally, if you haven't heard of it, or if you're a little rusty on that for anybody tuning in, is that if an input, a source is tainted, then anything that derives from that, a sink, if you will, is tainted as well, or at least considered to be tainted, potentially tainted. So
right, because a string that has the value AES is not a problem, unless it actually makes its way into a configuration function for a cryptographic primitive or certificate. And well, I mean, not that there's anything particularly wrong with AES, but if you needed to change from that to something else, then yeah, you would need to know that, and wouldn't want to be bogged down by the false positives of identifying strings that were incidentally harmless, right? Just because there's a string of natural language where someone said the letters RSA, you wouldn't want that, thousands of those on a report drowning out the one time that actually is selecting the something relevant to your application security.
Yeah, exactly. And I always, I don't know whether I came up with this or heard it somewhere, but a TLA is a TLA for a TLA, a 3-letter acronym, right?
Yes.
A TLA is a 3-letter acronym for a 3-letter acronym. And RSA or AES or anything else, EIEIO, I mean, all these are acronyms that they're not likely to be found in the wild, so to speak, but they could be. And those are false positives. You want to be able to monitor something. And something you mentioned, Sam, I'll kind of throw out as well. It's sort of like, this isn't a problem until we use it. It's like,
yeah,
if there's a yeah, that's mine too. It's so good, right? It involves a nursery rhyme or something. But anyway,
there's got to be a connection between that and what you said earlier about closing the barn door after the animals have left. Like old MacDonald had a cryptography algorithm.
There if there isn't, there should be. I always think back to, was it Cloudflare who had the lava lamps that was determining the random seed?
Yeah, that was cool. That was
the
very
lava
cool.
lamp wall, and it's like, okay, so that's completely analog input, and that's awesome.
Mm.
That's really, really awesome. So there probably is some kind of a cryptographic tie-in with a nursery rhyme there. We just may not be aware of it, but yeah. So I mean, you want to be able to trace that, and sort of like, again, you have a shortening electrical tool. It's not a problem until you plug it in, right? So this becomes a problem, and you need some mechanism so you can kind of trace throughout. So let's see. So we covered kind of the pattern scanning. We've covered the taint flow analysis and determining where that is a potential issue. And then I kind of, and I'll kind of hit this quickly, and then I'll show you very quickly just an example in our Moderne platform of our PQC recipe. And again, this is more a matter of kind of foster conversation than specifics, because I'm just using it on a default set of repos. So I'm not trying to poke anyone in the eye or anything, but the other thing that we typically do in order to stay ahead of this is constant recipe innovation and updates, because as time goes on, whether it's again a day, a week, a month, a year, we determine a little better how to analyze this and how to get closer to that perfection mark. And of course, you never can hit perfection. Every time you have a better algorithm, there's a better compromise that comes down the road. But
so even if you move to the best post-quantum secure algorithms of today, you wouldn't be able to ever fully be like, well, we're done with that. We solved that problem, because quantum computers and algorithms for trying to crack encryption secrets are going to continue to change in advance. So you need to not to achieve a fixed state, but achieve a state of agility where you're ready to change as needed, potentially continuously.
Yeah, and the other thing that really helps Moderne address this kind of thing is, I think, something that people don't really think about. So I'll happily remind. But when people develop a means of addressing something like this, if you or I were to do this kind of individually, what we might do is come up with a certain set of patterns that we would look for, and we might determine, okay, well, this feeds this. We can get all that, kind of individually, let's say, but where it really has where it really gains traction, where it really gains the power, is that by doing this, we can in turn run this against any number of repositories that we have ingested. So in our case, we have, I don't know, thousands, tens of thousands of repositories we have access to.
33,500 was
Here
the number in the app tenant when I glanced at that yesterday.
Yes. Well, I know you'd mentioned something about, I'll paraphrase, burning down the forest, that's a lot of, boiling the ocean, whatever you want to call it. That's a lot of data we can use, again, that code, data warehouse of your code. So we can say, well, here's a pattern that I'm seeing. Let's run this against these 33,000 plus repositories and see what comes up as far as false positives, or if we're close on the pattern, but we're a little off. Let's do the same thing with taint flow analysis. So we're looking at the gazintas and gazautas, and here's the problem.
The gazintas and gawatas? Sorry, what?
Gazintas and gazautas, yeah. So it goes into here and it goes out of here, and
I see. Yeah, the gazintas and the gazautas.
It's not a problem. Oh, it does match up. Okay, this is a problem because now we're hard coding a key length, and that potentially compromises this, which then in turn potentially compromises
and that key length is only 128, and that is probably not enough even for today, much less tomorrow.
Yeah. So this is the thing, that having literally 33,000 plus repositories gives you the ability to really, really hammer on quickly and iterate quickly. So again, and I mentioned this before, we don't know when it's going to happen. We don't know when quantum cryptography is going to basically obviate and eliminate the utility of conventional cryptography. We just know it's going to happen. We have a high degree of certainty it's going to happen. So it doesn't pay to get lazy. It pays to be prepared. So anyway, yeah. So that's kind of the summary version of it. Let me share my screen here really quickly, because I just want to show you something here.
Yeah, please do.
Share screen.
Tim, are there any good Netherlands idioms that are comparable to closing the barn doors after the animals have fled? Just taking a preventative measure after it's too late to prevent the thing.
We have one about covering up the well after the calf has drowned.
Oh, that's good. That's good.
Just to keep it light. Yeah.
Yeah, I guess the farm where the animals got out, slightly less tragic than the farm where the animals died, but similar sort of thing.
Okay,
I mean, so you have like 2/3 of a soup going there, so it's not a whole right.
Oh, there we go. Okay, so I should have let me drag this off to the other. There we go.
Ooh,
so
we briefly got a nice little infinity window.
Yes, I was trying to do the yeah. So okay, so
can we zoom this in, make this text a little bit bigger?
Let's see. Let's find out. Oh yeah, not terrible. Okay, so
there we go. That's more legible.
I ran a recipe that we have, and it's just post quantum cryptography recipe, and I just ran this against like 11 repos. So just did a quick run, and this gives you an idea of kind of some things and patterns that we're looking for. So we see some hard coded strings in here. We've got some things again that flow on down from these things. And it gives us some ideas on what we might be looking for. Let's see. So yeah, here's a glaring example. And here's what we're trying to avoid, right? So this is a very simple pattern. We've got a length here, a key size use that we're initializing, and we're hard coding that as well. These are things that we need to, again, just for general crypto agility, just as a general matter of today, we should be addressing, let alone worrying about what might happen down the road. But it certainly does make it a lot easier to address down the road when things get much more urgent. Let's see, what was I going to show after this?
Possibly the data tables.
So yeah, well, yes, I do have those as a matter of fact. So in this case, I can drill into this and see the code. I kind of short circuited this. Let me blow this up a little. So whoops, a little too much. So we can see here that we got the soccer algorithm as basically a constant and a static variable, which is determined to be a hard-coded string. Not ideal, as you might imagine. Let me pull up.
So looks like we got a question in the chat about how Moderne helps organizations identify and migrate legacy cryptographic implementations to quantum resistant ones at scale across large code bases. And this is so spot on. Is this one of our colleagues trying to help us out with the softball? Well, either way, recipes like the ones Mark are showing help you to identify the places where the configuration takes place. And then once you've identified where the configuration takes place and have identified what you would like to change that to, perhaps rather than hard coding the name of the algorithm, you want to connect to Vault or some other secret store or store of configuration to dynamically at runtime get what algorithm am I using, or possibly something at build time. Both strategies are valid. And then once you've identified both what needs to change and have an idea of what you want to change it to, well, that's just another recipe that goes and makes the change across all of your code bases in order to update them to say, instead of hard coding this, look it up or get it from this appropriate centralized source of configuration.
Yeah, and this is something that's I keep feeling like this is terribly underrated because people, many of us, and again, we're all guilty of this. We're human, right? So we all kind of fall into this. If it's not an immediate crisis, it's I'll deal with that tomorrow. I'll deal with that next week or month or year or whatever. But ultimately, the muscle you have exercised is what you are capable of employing very quickly. As you know, I'm a pilot, so you go through emergency procedures all the time. You work those not because you're going to have an engine out circumstance every week. I hope not. But the idea is that the muscle.
You might want to fire your mechanic if you manage to get back to the ground.
Yeah, funny. I just got my airplane out of annual, so yeah, let's not talk about that maybe too much. But the idea is that what you're familiar with, what you're comfortable with, what you don't have to think about to do is what you do. So you want that muscle to be well exercised and the procedures in place and just to be able to execute almost automatically, right? So one of the big things that we kind of undervalue, I think, in general in development is the ability to have a process in place, to have gone through that. And as Sam mentions, if you have a program in place that you push updates and again, just general crypto agility now, so that you can, we're going to update our encryption algorithm, or we're going to do a static analysis and maybe clean up our code and reformat it and maybe upgrade Java versions or very simple things. You have all these things in place. So it's a muscle you're used to exercising, right? It's nothing new. It's nothing, what are we going to do? You come in after the crypto, the quantum, switch is flipped and you don't have to think about it, right? You just execute the same type of process you've done before using Moderne platform or whatever, but in our case, it makes a lot of sense to do that because you can affect change across your entire code estate very quickly if you need to, and you'll definitely need to at that point. So if it's a muscle you've exercised, it's going to be execute. You don't think about it, you just do. So that's something that we have those processes established, and then you just get it done. So performance.
Another relevant question about the performance overhead of quantum-resistant algorithms compared to the current standards, and how should that influence future architectural decisions? I think this is a very relevant question. It's not one that I feel entirely qualified to answer, as I don't know the nitty-gritty implementation details of most of these algorithms, but processors are very fast these days, and it's not. For most things, you're not really going to notice if you're using like a key size of 496 as opposed to or 4000 and a higher key size than you may have chosen in the past. And even if I don't know, do you have any insights there, Mark?
Nothing specifically, because it's, as you might imagine, it's an evolving landscape. So right now, until we have something that actually it makes quantum computing economically viable, we don't have a way to see that, it completely obliterated our existing encryption, and here are the things we have in place. Obviously, things are under development, but without knowing exactly how that's going to unfold and when, it's still in flight, really. So What we do know is that obviously if we build things to be adaptable, if we build things to be hot swappable, we're ready. So, and at that point, if things do, if the walls, basically the shields come down, to use another Star Trek metaphor, since we're metaphoring the heck out of this, but once the shields come down, it's not, I guess, not necessarily going to matter if it takes 3 seconds to go ahead and recreate something versus 3 milliseconds. You just need something now. And at that point, obviously, when you implement that, then you can tweak performance. You can work on better optimizations, but you need to have something in place that you can swap in immediately and close those doors before all the horses get out. So, wow, I just beat the heck out of multiple metaphors in one.
Close the doors before the horses get out and drown in the well.
Yeah. Yes. And before the phaser bank goes dry. So yeah,
we really got to stop building wells right in front of the barn doors. Like that wasn't the best idea.
Yeah. Why did they think that was a good idea? Anyway, probably the person who has to haul the water. I don't know. But.
Yeah, and to the question about like performance, one thing is like not all things that you're encrypting need to stay secret forever, right? Like a transaction, like if you're placing an order on Amazon or something like that, that transaction needs to be encrypted so that no one can like redirect it or change your order like mid-flight, like do a man-in-the-middle attack on you and be like, rather than buying 1 roll of toilet paper, I would like to buy a Rolls Royce, and rather than have that shipped to your house, I would like that shipped to mine. Like that encryption has to work at that moment to avoid an attack. But if someone later on were to, decrypt it, they wouldn't really be able to do a whole heck of a lot with that stale data. So this something like that, where you're worried about like a temporary transaction being protected while it is in flight. Like if quantum cryptography enabled SSL breaking, man-in-the-middle attacks like tomorrow, then you would need to be able to switch your transactions tomorrow, but you wouldn't really need to worry about past stuff staying safe. But if you have like a secret that needs to stay a secret, not just now, but forever, well, use the biggest key size you possibly can, So that would be my my advice.
And yeah, there is an element to that. And sometimes you'll hear people talk about the harvest and hold. This is not something that necessarily addresses that. It's not something that can, because as long as somebody can gain access to that and hold on to, any kind of a data sync where it's encrypted, time is on their side at that point. It is now. It'll certainly be in the future. So that's not a problem that, in my estimation at least, is a pressing problem, because it's one that I'm not sure there is a solution to, other than making sure that there is no exfiltration of that kind of data to begin with. Which of course we're all trying to do. Everybody in every enterprise is trying to make sure that doesn't happen. But if that data is exfiltrated in any way, then that's not necessarily a solvable problem. You just want to make sure that what is secured and still maintained remains secured, or quickly as security is reestablished when as soon as possible. So yeah, so I mean, coming back to Sam's mention earlier, the data tables, there are several different data tables that are produced. I can flip through these. Oops, that's not what I intended to do. So let's see if I can. Yeah, so this is just the source.
I'm still seeing the abstract SSL context factory. I think maybe you're sharing this in a single window rather than your whole screen.
Yeah, that's weird that it's showing that, because I should be sharing the whole screen. Let me just stop sharing and reshare. How weird. Okay, so I specifically chose to share the screen, and
maybe you need to cancel the old share entirely. Like I still see the old screen is being shared.
I'm in the show. Let's see.
Right,
Share
cool.
screen. Share screen.
Maybe
Let me try to share the tab. No, the tab doesn't work. Hold on. Window. Oh, it was window is why. Never mind. Boy. Okay, so let's see. Let's do that. Yeah. Okay, that's better. So yeah, there are different. I mean,
so just to be clear, what we're looking at, this is a table produced by the post-quantum cryptography recipe run that we were showing us the results for earlier, right?
Yes, and every recipe can produce. Typically, will produce a couple or three different tables, data tables. which kind of include things like, oh, here are the files that were addressed, and here are errors that might have been encountered. But then you can also define different data tables you can create, or you can have the recipe create, I guess more formally, upon a run. So when you're running this against, in our case, I ran it against, like I said, I think an organization of 11 different repos, but again, potentially tens of thousands that it will produce. In this case, this is a security issues data table, and that is interesting in terms of it'll tell you what the particular issue is, find hard-coded SSL TLS protocol choices, find hard-coded.
When you scroll this to the right, I feel like there's another interesting column or two off to the right. See the left. Oh, no, that's it. Okay.
Not on that one. However, glad you mentioned that. That's just a source files results. The tape flow table is what I think you.
There we go. This is what I was expecting to see.
Yeah, and I can't really zoom that in any more without losing.
No.
But what I can't. Let's see. Yes, I can do that. So you
there
can
we
see
go. This is better.
Yeah, you can see the source and you can see the sink and why that's a particular problem. And then if we zoom back out, we can see the actual source file and where we're able to get to it, navigate to it, which is what I did, kind of shortcutting it earlier in terms of said, oh, look, this is this abstract SSL context factory. Let's go ahead and look at that and examine that, see the exact source line 49. And the other thing that we haven't really talked about is that each time you run a recipe, and this goes for any recipe, if you create a resultant data table from that, you can use that table as an input to the next recipe. So you can in turn take that and say, well, here's our findings that I'm getting from this particular recipe, and I want you to use that as the jumping off point for the next recipe for consideration, for analysis, for remediation advice, etc. So yeah, so that's kind of the nickel tour, but that gives you, I think, and gives folks, if they're kind of new to this realm, a little bit of an idea in terms of why it's so important to have not just a pattern matcher, but in terms of the ability to look at sources and sinks and see, is this really a particular problem? So great example, again, we've got RSA. Well, is that a problem? Well, when you're doing a get instance on a key factory, it is. Or same thing with the SSL context get instance socket algorithm. Well, what's that? Well, it's SSL. That's potentially problematic. So it gives you that context you need to see if something really is a problem or if it is not.
Take inventory and first understand where it is you stand.
Yes.
And on the subject of data flow and taint tracking, these are more generally useful tools that can be used for a whole variety of different things, security scenarios, but also, I don't know, any time that it might be relevant that a particular input makes it from one place to a particular output, or vice versa. And I believe that we are going to have a code remix scheduled. I don't know if we've picked the day yet, but where I will be covering how to write recipes that make use of the data tracking and taint flow capabilities so that you could apply these techniques to your own scenarios, whether those were post PQC or anything else. Yeah.
And again, I think sometimes and it's the bias that you mentioned earlier, you assume everybody's kind of at the same level. There are some who are obviously farther along, but there are many of us who, I always say everybody's a noob at something. So you can be an absolute expert in one particular area, one particular topic, but we're noobs at far more things than we're expert in, and always will be. Hopefully, hopefully we'll always be learning in different areas. So I think it's instructive to note that all of these things, as far as creating a basic recipe and being able to determine, oh, I want to create a data table, and what does this do for me? Well, not much if you're doing a very simple recipe, but then you can use that same concept and build out. So it's very foundational, and that allows us to do things which seem terribly clever when you think about them in terms of chaining those recipes and following the flow across multiple recipe runs, across so many things you can do that build on that very small foundational nugget. So anyway, I will say I wore this shirt specifically for this. So
there you go. Very nice choice.
Yeah.
And indeed, that session on taint flow and data flow tracking, that's going to be December 10th. So in just under a month, we'll be able to you'll all learn how to write recipes in that space.
Don't want to miss it.
Yep. Yeah.
And I want to hook in briefly on something that you mentioned earlier, like how do you keep that flexibility and how do you make sure that you're ready to swap in different encryption standards? Well, one part of that is staying up to date with Java. If you look towards the releases in the 21 and 25, it's not typically the very sexy features that folks write blogs about and things like that. But there has been some features in 21 where there's a new key encryption standard, and there's a new key derivation API in Java 25. And all of those allow you to swap in, now that you have that data table of what are you using currently to what you want to be using that you think is going to be more quantum secure, to be able to swap that in the moment that you are up to date on your Java versions to be able to use those new APIs. So just figured tie that in because it always gets overlooked a bit in the migration guides, but there is real value in just staying up to date there as well.
Excellent call out, Tim. Absolutely.
Absolutely.
And I must admit, it's also the features that I tend to like skip past when reading a migration guide. So I think, well, that's not today, but maybe it should be somewhere on your calendar for at least the coming weeks, coming months. Of
course. Absolutely. Yeah, I'm much more excited. Immediately like, a new way of doing like string templating, or a faster garbage collector. But that stuff is important too.
Mm-hmm.
All right. Well, we've been blabbing for about an hour now. Does anyone have any closing remarks before we end the stream? Tim, anything else from you?
No. Just I don't know. Looking ahead at next week when we're gonna have you on holiday for the next 2 weeks, I think. So
next 2 weeks. I'm planning to be in Australia, assuming the planes will get me there and hopefully get me back. So if things go poorly, maybe I will be here next week, but probably I will be in Australia.
I think you'll lose at least 1 day on the first flight out, right? Should be good. No,
there's no avoiding it when you fly across the Pacific. It's big. It's real big. I don't know if you guys have heard that.
Yeah,
but, it's big.
Yep, been to Australia. It's the forever flight. So
yeah. I've been to Australia once before, and it was the worst flight I'd ever taken. It was because I learned something new about myself that day. Because up to that point, I'd never had any problem with turbulence or air sickness. Things that spin me around, rides that go up and down, roller coasters, love it, love all that stuff. Never had any discomfort from dizziness. So the planes all rattling around as we're somewhere over the ocean, and I'm not feeling particularly bothered by that. So I try to go to sleep because it's a very, very long flight, and it wasn't at first I had to fly across the U.S. to get to California to even begin embarking on that flight. So I was very tired. But it taught me that there's one circumstance where I will get very motion sick, and that is if I'm trying to fall asleep and it's turbulent, because I woke up in the process of throwing up. So that was the first and only time I've ever thrown up from air sickness on a plane. So I'm hoping that the turbulence this time is minimal. But if it isn't, I'm gonna know to just power through and not try and take a nap.
Usually, and I think they've gotten really not a little lax about this, but usually there's an air sickness bag, or what we call a sick-sack, in the back of the seat right in front of you. So might not be a bad idea just to locate that. I mean, that's a good tip in general. Just know where the emergency provisions are in advance, which I think is really relevant to post-quantum cryptography.
Yes, in case quantum computers are going to get turbulent and barf all over your secure communications, know where your barf bags are. I think that's a good summation of everything we've talked about today. You should probably just leave it there.
Yeah. It's funny because it was a really bad flight not that long ago, and I mean I don't normally get airsick or something, but they mentioned over the PA that if anybody does get airsick, there should be, and it was I don't remember the exact wording, but there will be an air sickness bag in your seat back pocket in front of you, or there should be, or something. And I was like, huh. And now ever since I've checked all the flights, and it's like 1 out of 10, it's there, and the other 9, it's like good luck.
But you can almost find the card with all the advertisements of the things the airline would like to sell you. I know that one you could find reliably.
Yes, their menu and how much each item costs that you can order a la carte. Yeah, that's there.
Mm-hmm.
That's always there.
Just need to learn some origami to make it multifunctional, and then
Excellent
Right.
point. Excellent point. All right. Thanks everyone for joining us. Appreciated having such a lively comment section this time, or a lively chat. Yeah, do feel free to send us your programming memes if you find some good ones. I'll feature those on a future episode. And thank you, Mark, for joining us and for the lively and poetic discussion of barns and barf bags. It has
Yes.
it's been a pleasure.
Yeah, I came ready. Thank you. Always a pleasure, guys.
All right. Thanks a lot, everyone.
Thanks all.
And look forward to seeing Tim, but not me next week. And if you do see me, and I'll be looking grumpy and annoyed to be here because I should have been in Australia. And until then, bye for now.
Bye all.
Bye.